Hi everyone, I'm Shubhasri Datta, Associate Professor of University of Engineering and Management, Kolkata. So today I'm going to deliver a lecture on introduction of matrix. It will contain matrix as well as determinant and along with the properties, how it will function on different matrices, their properties, everything. So we will start with the introduction. First is what is a definition of a matrix? So definition of matrix is telling a matrix is a rectangular array of numbers, symbols, and expression arranged in rows and columns. So that means there can be different type of matrices, which is an array of numbers which can be along row wise, along column wise, or both row and column. So first is row matrix. Row matrix is when a single row with multiple columns. So example we can take as one row with multiple like 1 0 0. So it can be a row matrix. So there will be one row and n number of columns. Similarly, column matrix is there will be one column and n number of row. N can be 1 2 or n, like 1 1 1. So this is a column matrix. So square matrix means it's a matrix which will have both rows and columns more than one, and square means the number of rows and columns are equal. That means 1 1 2 1. So this is called a square matrix. Rectangular matrices, it will have more than one row and column, and rows are not equal to the column matrix. So this is an example of a rectangular matrix which is having two rows and three columns. So this is a rectangular matrix. This is a column matrix and this is a square matrix. So these are some examples. So now we will see. Acha. So now we will see some properties of matrix. So in matrix you can do addition as well as like numbers, whatever you can do. For matrix you can do those all, but the condition is there are some properties that you have to maintain. The first we will see the addition. Suppose there are two matrices A and B. This is A, which is a square matrix. This is B, this is a square matrix. So you have to keep in mind that when you are doing addition between two matrices, then the number of rows and number of column of those two matrices should be same. Otherwise you cannot add or you cannot subtract. So these two matrices will have same number of rows, which is 2, and same number of column is 2. So if a matrix is this type, so we will write the order as 2 cross 2. This is the number of row and this is the number of column. So it's a 2 cross 2 matrix plus addition we are doing with a again it's a 2 cross 2 matrix. So after addition it will be so how the operation of addition will operate on matrix. So when you add to matrix A, they will be added component wise. So the first this position, this is called A11. So A11, like A11, a matrix you can write in this way: A11, A12, A21, A22. Like so, this one will be added with 2. So this is the first element. A12 will be multiplied with B12. So this is the second element. Similarly, third and fourth. So this is the output matrix. Similarly, when you do the subtraction, same also you have to keep in mind that both the two rows and columns must be same. A number of row, number of columns. So again, it will be component wise. It will be subtracted. So this is the output matrix. Achha. Now the scalar multiplication. The scalar multiplication means scalar will be multiplied with a matrix. So when you multiply a scalar, so here 3 is a scalar and C is this matrix. When 3 is multiplied with this matrix, so you have to keep in mind this scalar 3 will be multiplied with each term. So with each term, the scalar will be multiplied. So the output matrix is 6 minus 3, 0 and 9. You cannot multiply it with only one row or one column. You have to multiply it with all the rows and columns. So next, we will see the multiplication of two matrices. Suppose one matrix is A M N. A M N means it is containing M row and N columns. So similarly, B N P means it is containing N row and P columns. So a matrix multiplication is allowed when these two numbers are same. This N will be this N. Then only we can tell it is multi multiplicable. So it is multiplicable if and only if this number of column of the first one and the number of row of the first one is same. So then you can multiply AB, but you cannot do BA. BA is not possible because if you keep B on the front, then the number of column P is not equals to M. So you cannot do BA, it's AB. So C equals to AB. So so now we will see how this operates. So suppose A is this matrix, B is this matrix. These are all 2 cross 2 matrices. So when you do A cross B, then what you have to do, just see this one, just this row along with the multiplication with this column. So first take A, since we are writing A, B, first you have to see A, check the first row, multiply it with the first column and then add. So it's 1 into 5 plus 2 into 7. Next element is 1 into 2 into 6 into 8. This is the second element. For the third one, you have to take the second row multiplied with the first column. Next is second row multiplied with the second column. So this is the output matrix. So this is how you have to do it. So we can see another example. Suppose I'm multiplying a matrix A, 3 cross 2 matrices. Suppose it's A, 3 cross 2 matrix. We are multiplied with the B, which is 2 cross 4 matrix. It's obviously multiplicable because these two are same. So this is A, this is B. So when you multiply A into B, so take the first row multiplied with the first column. Take the first row multiplied with the second column, first row, third column, first row, fourth column. This will be this element. Similarly, for this, you have to do all, and this you have to do all. So this is the output matrix. So now there are some matrix which are very well known, and we also have to know this because if you take the name, you have to understand I'm telling about this matrix. So first is identity matrix. So identity matrix we will denote by IN. So always identity matrix is a square matrix. You cannot take identity matrix as a rectangular matrix, column matrix, or row matrix. It's always a square matrix, and the number of rows and number of columns which are equal, which is n is this one. So how to write in will be in this form. In equals to 1 Diagonally, you have to take 1. How many times? N times, because they're an n row, and rest all the other elements are 0. So I3 will be, just write down 3, 1. Diagonally, all will be 1. This is called principal diagonal. Diagonally, this is 1, and rest other element, rest all the elements are 0. Similarly, I4 means keep 4, 1, and then other 0. Similarly, IN is this one. So similarly, what is zero matrix? Zero matrix is when all the elements are 0. There is no element except 0. Then it's called a zero matrix. So zero matrix is also a square matrix, and 0, 3 cross 3 means all the rows and all the columns are 0. So in the next day, we will proceed for the next part of matrices, the operations, as well as we will go for the eigenvalue and eigenvectors. Thank you.